I'm recording. Hi, everybody. Back to my house. Uh, Enjoying the smoke apocalypse, which is really not very fun at all. Anyway, so if you hear dogs barking or octogenarian in-laws uh, yelling in their deaf voices or 16-year-old kids eating cereal, that's my life. Anyway, yesterday I played Darwin's Demons 4 additional times so that I could replicate our little experiment testing the hypothesis that dominance is under selection. I've also had a request from Sam Preston, who's working far ahead, to describe what all of those columns are in these Darwin's Demons data files. So I will try to put a spreadsheet up on bblearn that does that, so that you can test this type of hypothesis with other traits besides dominance. Sam intuited that because I'm doing dominance in these videos, maybe you guys shouldn't do dominance for your experiments because you will know the outcome. And actually, if you want to do dominance, it's fine. Use a different ship than I did, or, it's not necessarily true that different conditions of playing the game might always cause dominance to be under selection. And remember, science is about replication. So in addition to replicating the experiment properly here, what I'm doing today, don't forget that in order for us to sort of convert a single scientific insight into something that's a little bit more grounded towards like, hey, we really think this is what's going on, other people would have to replicate that exact same experiment. So actually, feel free to replicate exactly what I am doing with dominance, and let's see if you get the same results. Maybe you don't. Maybe different players might have something to do with the selection patterns on traits in this game. So what you're seeing here is a couple of Finder windows. And so this first Finder window is the data directory that you get to when you click Open Data Path in Darwin's Demons. And it's this path down below that you can see here. And what I did is I sorted it by date modified, which is the date the files were created. And we've got 4 new data files that I created yesterday in the middle of the day. And then my day went completely sideways with COVID testing oversight stuff. And I never got a chance to record this video. And what I did was I very carefully recorded the order in which I conducted the experiments. And I can tell you that the first 2 that I did at 11:20 and 11:31 were control replicates, where I turned off all of the fitness functions. And then the next 2 were selection replicates, where I did everything the same except I had accuracy and aggression fitness functions turned on. And now I'm going to show you how to ingest all of these data files into our script, our R script, and analyze them according to the metadata. So this is going to be a bit of kind of data wrangling, or in data science we call this janitorial work. There's this thing called the 80-20 rule in data science. And it specifies that typically a data scientist spends 80% of their time cleaning and manipulating and getting the data ready for analysis, and 20% of the time doing the analysis. So we're about to do something like that. So we already have, I'll show you where this is going. This is my directory where I've been doing this work. And you see the 9.3 and the 9.10 data files. That's what we've already been working with. So we already have those. I need the 9.14 data files. So I'm going to select those by clicking on one and then holding down Shift. And then I'm going to hit Command C to copy them out of my Darwin's Demons directory. I'm going to go over to this other Finder window, which is my working directory for analysis, and paste them in. Okay, and you can see that the date modified stuff stays the same on a Mac. In theory, all of this is possible to do on a PC, but If you're struggling with the PC version of what I'm doing, just shoot me a text or an email. We'll work through it. For the three of you that are actually following along. All right, here's the thing. I'm going to change these file names. And I'm doing that because I want to add some metadata to our analysis that can help me differentiate between control and selection on replicates. So I'm going to change these file names to reflect what conditions they were run under. And so there's a lot of ways we can do this. I think what I'm going to do is add a character to the beginning of each file name that indicates whether they were run under conditions of natural selection or conditions of natural selection off. And I think what I'm going to use is C for control and S for selection. Okay? So, and I've got my notes here, so I know which files were run under which conditions. This is one thing I wish we'd have put into Darwin's Demons to make it easier. You have to record which file is which. If you don't pay attention to that, then we're kind of screwed. We can't remember what was what. This is an important part of scientific work, is taking really, really detailed notes. And a lot of times people are like, I don't need to write that down, I'll remember it. If you ever catch yourself saying that, you're wrong, and stop it. You're going to regret that. Got it? So, according to my notes, this file, the 9.3 file, was an evolution replicate. So I'm going to click on that, and I'm going to add an E to the front of it. And then the next file, 9.10, was a control replicate, and I'll add a C to the front of that. The next two files, according to the notes that I took, were both control replicates. So I'm going to add a C to the front of those. And then the last two here that I ran yesterday were evolution replicates. And you can see it automatically sorts as I change here, so watch out for that. All right. So I've just added a single character to the beginning of each file name, and we're going to use that information to help us track which file is associated with what type of treatment, control or evolution on. I think I said I was going to use S. Oh man, I'm dumb. E for evolution, S for selection. Buh. All right, so now let's run off to RStudio, which I happen to have open, and this is the program that I uploaded. Stop texting me, people. That's Dr. Neusmer. So this is the file that we had started with. We were just doing a facet thing. And we can just run this just as is. And that's what I'm going to do. And I'll show you what the graph looks like. And then I'll show you how we can use that C/E treatment variable to add richness to our data visualization. So if I just hit Command A, it selects all of my script, and I'll hit Command Enter, and we'll run it. And you'll see that it read all of the data in, and it made ourselves a graph. So it read each file in, added it to this data frame we called all the data. Okay, and then we had it facet it out, and we just made scatter plots. So if I zoom in on that plot, every dot in here is an individual alien, and the facet command in ggplot has made a graph facet for each different data file. And I will just jump back to RStudio really quick, and I'll show you that. So we said, hey, take all the data frame, all the data, and we want generation on the x-axis and dominance on the y-axis, and we want every value of the file variable to be a different color, and I want you to make just a standard point, xy point scatter plot kind of graph, so every alien has its own data point. And I want you to facet the graph so that every file has its own separate graph. And then when we do that, that's what we get. It's okay, it's not pretty, and it's not particularly useful. If you handed this to a reviewer, they'd be like, what the hell is this? What is file, C data, blah, blah, blah. So we have some work to do. But you can see there appears to be something going on here, wouldn't you say? Like, just coincidentally, R has organized our plots so that the C files are at the top. Those are all our controls. And the E files, where the selection or the fitness functions are turned on, are all down at the bottom. And you can see it sure looks like dominance is going down relative to the controls. And in the next video, we'll do a statistical analysis of that. So, we've done it. Not good enough yet, though. We need to make a visualization that a reviewer, a third party who doesn't know anything about your experiment, could digest all of the information we want to give them very easily. So let's get rid of this and add a little bit to our, and again, I'm going to try to do this from memory and remember what happened last time I did that. We got errors. So we'll just it'll be fun. Just trust me. Just trust me. Remember, if you're thinking to yourself, I don't need to write that down, I'll remember it. You won't remember it. Off we go. What I'm going to do is I'm going to open up an old R file. I think this one has what I want. It does. Okay. And instead of trying to type it from memory, I'm going to go ahead and copy this this piece of code here and paste it in, and I'll tell you what it is. Okay. This, there it goes saying okay again. We have to hook up that Twitch stream with the auto shock. This command is creating a variable called SST, which is, this was, again, Sam Hunter was teaching me how to do this a long time ago, and we use this variable. It stands for string split. It's, again, generally speaking, things on the left-hand side of this assignment operator are variable names, and we could just as easily call this, in fact, let's do it. I'll show you. I will call it, I'm really bad at naming things, and I tend to name my variables really dumb variable names. Let's call it, well, I don't want to call it Cthulhu. That'll just contain, let's call it meta, because this is really what we're doing is we're harvesting metadata contained in the file names. So we're going to call it meta. This variable meta is assigned this stuff. And this T means transpose. And then what we're saying is convert to a data frame the result of this operation. This is really what this is the core operation here, string split. It's saying a string is a set of characters, like my name, Barry. And if we say string split Barry, and we don't use any separators, it would just be BARRIE. Okay? But in this case, we're string splitting the value of CSV. And see when I highlight this? Okay? CSV is our variable name that essentially is the file name. And what we're saying is take this value CSV, which is the file name, and make a data frame out of all of the characters in the file name. And then these double quotes that have nothing in them, that's essentially saying use the separator nothing. And what that does is it just slices every single value of the file name. and it puts it in a data frame, and we're transposing it because by default that command would make a vector that's up and down, and every individual character would be a row. But we want it to be flipped so that every individual character is a column in a data frame. We're just doing this to get access to the first character in that data frame. And so if we just run that command and then we go look at meta, you can see so this is the row name essentially, and every single character is a variable. And that's really messy, and really we're just doing that as an intermediary step. What we really want is this first thing that we put in. It's either going to be an E or a C. Okay. So I said okay again. I tried not to. I even thought about it and I did it anyway. Oh, so frustrating. So now we have this new data frame that just is a bunch of letters and numbers associated with our file name. We really are interested in that first character because we put those in to add metadata to each file. And we're going to create, just like we did here, a new variable in our all the data file. So we'll go D, open a square bracket, open a single quote, and we're going to call that, let's call it selection. And if selection has a value of C, it means it was the control state. And if selection has a value of E, it means it was the putative evolution state. And to that new variable selection, we are going to assign the value of string split that is in the first row and the first column. And I'm just going to go back here to double check. Oops, no, not that one. This one. All right. So the first row and the first column, that's how you sort of get something, is you use these square brackets. And you're like, go into this data frame. And in position 1, 1, that would be A1 if it was an Excel sheet, assign that to this value of this new variable selection. And so I'm going to, actually I'll keep this plot. And what I'm going to do is I'm going to rerun our for loop here. And so let's actually, before I rerun the for loop, let's look at all the data. And we've got 60 variables, and at the very end, the last data is the file, the last variable is the file name. And now, if we rerun our for loop, oop. Ay, ay, ay. I forgot I renamed it. We gotta go, I renamed it meta, so we gotta go to meta. Oh, jeez. I think I gotta leave these errors in, right? So that you guys can see this is an iterative process filled with Googling the error message. And now the number of columns do not match. Oh, I have to reset this. There we go. I had to recreate I had to empty the data frame, all the data. And now, instead of 60 variables, we have 61. And if we go to all the data and we go across to the right, we've got a new variable called selection, and it can have a value of C for the control state or E for the evolution state. And now we're going to use that at the end of this video to add a little bit of information to our plot. And so what we did before is we said, hey, take all the data, plot dominance against generation, give each file a separate color, make a scatter plot, and then separate the values of each file. I'm going to make one small change here, and that should actually add a reasonable amount of value to our plot. I'm going to change this word file to our new variable selection, and let's see what happens. And now, remember, when you're visualizing data, you want to try to draw attention to deliberately to a comparison. And in this case, the comparison that we are interested in making is between the two different values of that selection variable, control conditions versus conditions in which evolution is activated. And so now, we don't have a bunch of very distracting colors and all of that kind of stuff. We have two colors, and the control stuff is on the top, and the evolution condition is on the bottom. And it's very easy to sort of make that logical comparison. And so I'm going to end the video here, and then I'll do another one real quick here where I pick up here, and we're going to add trend lines to this where we add averages. But our hypothesis, just to circle back to the hypothesis and the prediction, our hypothesis is that the trait dominance is under selection. And we predict that if we turn the fitness functions off, if our hypothesis is true, then dominance should change when the fitness functions are on, and when we turn them off, dominance should really not change over time at all. And I would say that we haven't done a statistical analysis, but these patterns visually are consistent with the prediction of our hypothesis. All right, so I'm going to shut this down. I'll edit this video, post it, and then we'll do another quick one. Okay, I'm looking away. Oh, I said okay again. Oh, geez. Anyway, bye.